All right, let's do another example. Here we go. We've got this quotient rule, and we're going to try it out. So I want to begin by saying that y prime, we'll just put some arrows here to get us started. So y prime is the derivative of the top, which you should be able to write down is 2x, times the bottom, which is x cubed plus 5x. All right, then I'm going to subtract the top, x squared minus 3, times the derivative of the bottom, which is 3x squared plus 5, all over the bottom, x cubed plus 5x, all squared. So that's the first step. And I want to point out to you something really important. You need to realize that at this point, you are done taking derivatives. You have done the calculus, and everything else you do is just algebra. And to be perfectly frank, it's the algebra that tends to get people. So let's carefully work out the algebra and go from here. So I'm going to say y prime is, and I don't need to expand the bottom. We said that last time. There's no reason to expand factors in the denominator, but you do want to expand things upstairs because it allows you to combine like terms. I'm going to factor the bottom in a minute as well, though. I will do that. But let's dive in. So expanding things out, I'm going to get what? A 2x to the fourth plus a 10x squared minus parenthesis. Now I'm going to expand this out. And let's see, we're going to get a 3x to the fourth, plus a 5x squared minus a 9x squared minus a 15. That's everything upstairs, all over. I'm going to write this as x times x squared plus 5, all squared. Right? I can pop an x out and write it like that. And the whole thing, I should put another parenthesis here. The whole thing is being squared. There we go. Okay, so next line, I'm going to push this negative through, and then I'm going to go ahead and combine everything that I can. So for example, this is just negative 4x squared. I'm going to add that with this one. I'm going to combine these two, so on and so forth. And so when we do that, we get that y prime is negative x to the fourth plus a 14x squared plus a 15 all over x squared times x squared plus 5 squared. Pushing that squared to each one of those factors, just in case I can cancel. Now, sometimes you can factor upstairs, sometimes you can't. I can in this case. And please check, pause the video, factor this yourself. You should get negative x squared minus 15 times an x squared plus 1 all over x squared times x squared plus 5 squared. And so at this point, I'm done, and I want to point out to you, we did more lines of algebra than we did actually calculus. The quotient rule just put me right here. Cleaning it up, boiling it down to here took a lot of time. And what's the point of all of that? Why can't you just leave it here? Well, sometimes factors up here and factors down here will actually cancel and significantly clean up your answers. All right, well, I want to do another example with you. This is an example that you'll need to know the formula for. So it's not just a random example, it's a very intentional example. It's a question you should be wondering. What's the derivative of tangent? We can take the derivative of sine and cosine, but we haven't written down the derivative of tangent. And the reason is we've been waiting to get to the quotient rule. And the whole point is you can write tangent as sine of x over cosine of x. And so now I can go ahead and begin to write f prime using the quotient rule. Derivative of the top, derivative of sine, you know, is cosine of x times the bottom, so times the cosine of x, minus the top, sine x, times the derivative of the bottom, which is a minus sine x. The derivative of cosine is minus sine x, all over the bottom squared, so that's a cosine squared of x. Think with me, this is cosine squared minus a minus, so plus sine squared. Cosine squared plus sine squared is just 1, and so this is exactly 1 over cosine squared x, which of course we know is secant squared of x. And so the whole point is that the derivative of the tangent of x is the secant squared of x. And you can actually, at this point, armed with the rules that you have, you can work out the derivative of all the other trig functions. But I thought I would just write them down for you. So the derivative of secant, for example, is secant x times tangent x. The derivative of cotangent is minus cosecant squared. The derivative of cosecant is minus cosecant x cotangent x. People sometimes don't write the x's, which is not a good idea. I do want to give you just a little handy-dandy table that I sort of learned a long time ago. I forget who showed me this, but it really helps keep track of all of these types of things. And so you can just write down tan secant and secant like this. Whoops. And then you can write down cotan minus cosecant. And now, basically, the idea is this helps you keep track of the different derivative formulas. You need to know the derivative of sine is cosine, the derivative of cosine is minus sine, the derivative of tangent is here. Yeah, so sorry. You just need the derivative of sine and cosine. Everything else is here. So the derivative of tangent, you just multiply these two, secant squared. Do you see it? The derivative of secant is secant tangent. And so just writing this down and sort of knowing how that works, you don't have to work so hard to memorize those. For example, the derivative of cotangent is minus cosecant squared. Done. And the derivative of cosecant is minus cosecant cotangent. So this little sort of memory device really helps you keep track of the other 4 trig functions. So you need to know sine and cosine and then be able to write the other ones down. All right, let's break this video here and then we'll do some examples in the next one.